Web shells, smart scripts with a massive impact. They are one of the most common tools hackers and attackers use to silently gain a foothold in a compromised or hacked system. However, for SOC analysts and incident responders, knowing how to detect these web shells isn't just helpful, it is essential. These backdoors give hackers remote control, enabling everything from reconnaissance to privilege escalation and data exfiltration. In this video, we're going to start with a quick refresher on what are web shells, then walk through practical detection techniques using logs, monitoring tools, and proven analysis methods. And we're gonna solve the room from TryHackMe detecting web shells. So, what are we waiting for? Let's get started. Okay, let's start by exploring the web shell. So basically, a web shell is a piece of program, a file, could be written in PHP, could be written in any other programming language that once uploaded to a web server can enable a variety of access features for the attacker. Let's first start by understanding and learning how a web shell is uploaded to a target web server. So a web shell is uploaded by exploiting certain web vulnerability. By exploiting a certain web vulnerability, you'll be able to upload the web shell. For example, if the server has a file upload vulnerability or a misconfiguration in uploading files to the web server, like permissions misconfigurations, attackers can upload a web shell. Once a web shell is uploaded, the attackers can perform a variety of actions. They can establish persistence so that they can get back to the machine or get back to the victim machine whenever they want and execute system commands. They can perform reconnaissance. So by executing commands such as nmap on the machine, they will be able to gather information about other systems that the machine might be connected to. They can also perform privilege escalation using maybe automated tools such as LinPEAS or WinPEAS, depending on the system. Attackers also, after uploading a web shell, they can perform lateral movement. They can discover other systems that the machine might be connected to, and they can exfiltrate data as well through the use of netcat, FTP, or other methods where they can pull data from the machine to their command and control server. So basically, these are the things that the attacker can do once they upload a web shell. That's why a web shell should be studied. You should be able to know how a web shell is uploaded. And of course, we should be able to detect web shells on suspected web servers. Now, an example is laid down in the room that we are about to solve. And this example is here. So it's a web shell. The name of the web shell is a web shell. And that's how it looks like once uploaded to the web server. You see, this is the box where you can input the command. And once the command is executed through the run button, you would see the end result by looking at the command output. You see the output is very similar to the output you get when you execute this command in a regular Linux terminal. Because this command is executed in the underlying system that hosts the application, which happens to be, in our case here, Linux operating system. All right, now let's start answering some questions here. So which MITRE, ATT&CK, persistence sub-technique are web shells associated with? So you got to look at the persistence techniques using the MITRE ATT&CK navigator. So you go to the official navigator, and here we look at persistence. Exfiltration, command control, collection. So you got persistence here, and we have to see the sub-techniques. So basically, to see the sub-techniques, we can click on the button Show Sub-Techniques here. And once doing that, we can go back to persistence tactic, and then scrolling down, and here we look for web shell. So this is the web shell, as you can see, which is a sub-technique of server software component. We click on web shell and we can grab the ID. What file extension is commonly used for web shells targeting Microsoft Exchange? So everything that is related to Microsoft products, Microsoft IIS, Exchange, the web shell that's commonly used to exploit these applications has an extension ASPX. Okay, now let me show you examples of web shells. So web shells can be one-liners, such as this one, or can be composed of multiple lines, or can be fully functional web shells, such as Pony shell, P374K shell, C99 shell. These all can be found in GitHub. For example, this one, let's have a look at Pony shell. So this is a fully functional web shell that can be uploaded to your targets, and once uploaded, you will be able to execute the system commands. Let's go back. There also can be one-liners, such as this one. So see, this one starts with the echo statement and then uses the shell execute PHP function to execute a system command through the CMD parameter. So this can be stored in a PHP file and directly uploaded to your target web server. Once uploaded, you'll be able to execute the system commands by passing the commands through the CMD parameter. And this is also another one-liner that uses the system function in PHP. You see, web shells use or abuse basically PHP or system functions such as shell execute, system, and also we have this one. So this one first checks whether the CMD parameter exists in the request, and if it exists, it passes the commands through the CMD parameter and store them in a CMD variable. And then after the command is passed and stored in the CMD variable, it is executed through the system function. Basically, there's another example laid down in the room here if you want to check out the room. This example is very much similar to the example I have here. However, here it is passed through the CMD parameter, and then as you can see, the output is formatted for the user interface using HTML, so that you get a box here where you pass the command instead of passing the command directly through the CMD using the web browser. So without this part, or without this portion here, the form, you have to pass the commands through the URL by using the CMD parameter, and here instead of whoami, you pass the command that you want to execute. Now, with the existence of this HTML form, you can see we are able to execute the commands or pass the commands through the input form. In the TryHackMe room, the web shell is deployed in the application and can be accessed using the following URL. You see, the example web shell here used is a web shell, and it is a PHP web shell as can be seen in the URL. Now we have basically an input box to pass the commands. So we can execute whoami, run, and we can monitor the URL how it was changed. So you see the CMD parameter now appears, and it contains the command that we have passed through the input box. We call this the parameter that's used to pass our command to the underlying system. Okay. So sometimes you do not see this input box. Okay. Sometimes you upload the web shell, and from here you can execute the command directly. You don't have to interact with the form here. So for example, through the CMD parameter, I can change whoami and use maybe ID. As you can see, the command output changed. Let's go back to the task 2, I believe, task 3. So access the shell and determine which account you have access to by running the whoami command. So going back here, whoami, and we are the web server user. Typically, this is the Apache web server user, the data. List the directory contents and find the flag using the ls and cat commands. Okay, so we use ls. So treat the web shell just like the Linux terminal. Run. So we have two files, a web shell, which is the web shell we are using, and the flag. So use cat to display the contents of the flag. Okay, task 3 is out of the way. Now let's move on to the part where we learn how to detect web shells. So here we're looking at the logs. These are basically Apache web server logs. And as you can see, first indicator of a web shell being uploaded to the web server, or an attacker trying to upload a web shell, is repeated GET requests. You see we have many GET requests to various files. First we have upload the same file, actually, but as you can see, different extensions. First, we have ASPX, PHP, ASPX. So basically, the attacker trying to guess the upload directory and the uploaded file name. And as you can see, the attacker also trying to figure this out by probing the download directory. So repeated GET requests to the same directory could indicate that the attacker is trying to find out what is the location where the uploaded files get stored, especially if the request is going to the location, the very location that's used to upload files. Next, we see a post request to the uploaded file, and then we have multiple GET requests. So this is another indicator. When you see a POST request followed by multiple GET requests to the same file, which was the subject of the POST request, this is another indicator that the attacker was successful in uploading a web shell and now is interacting with the shell through sending GET requests. Now, another method to detect web shells is by inspecting, again, the logs. But this time, instead of looking at the HTTP requests, we are looking at the user agents. So altered user agents, for example, have a look at this one. This one here, as you can see, this is a user agent for Mozilla, but this time, if it is modified to or shortened to this version, it indicates that the user agent is altered, and thus it is used for purposes not intended to be used. Another example is outdated user agent. For example, here we have this one, which is released in 2001. This indicates that this also could be an attempt. It's not definitive. Most of the time, when you detect indicators of compromise, you have to correlate the results from different sources or from different angles. One angle isn't enough. And blacklisted user agents, for example, using curl in requests is blacklisted and indicates suspicious activity. And requests coming from suspicious IP addresses, as I have outlined here. And of course, query strings. When we look at query strings, the query strings should be familiar. For example, look at this one. Example.php query equals some query. This parameter query is familiar. However, when I see CMD or exec, it is not familiar, right? It indicates that there might be a web shell being uploaded or already has been uploaded. When I see query strings whose values are encoded with base64, this is also not familiar. So also, query strings are a place to look at when investigating for web shell presence. So you were inspecting the logs and you found this query. Take a look at this one. So this query comes from, as assumed by TryHackMe, a blacklisted IP address. Okay. And then we have a timestamp, indicates an access outside of regular business hours. That's another live indicator. And then we have a post request to a suspicious file. So why this file is suspicious? First, you can judge it by the name, and you can judge the file by how it looks. Basically, as a web server administrator or SOC analyst, you should be familiar with the type of files that could exist or may exist in the web server. So any weird looking or strange file is probably a suspicious file. And then we have, you see the query parameter here is CMD, which is not a good indicator. And then we have a user agent that's curl. Curl is a blacklisted user agent most of the time, not all of the time, of course. Lastly, there are two questions. What's the part of the URL that associates files or values to parameters and can be a valuable indicator of web shell activity? You see, it is the query string. What Auditd Syscall? Auditd is a tool in Linux that can be used to create logs. Would confirm that the file was written to disk following a suspicious post request. It is the create. Okay, now we have task 5, 6. So beside the access logs in your web server, you could also look in your web server files. Depending on your web server type, you might look for different file paths. For example, if you are using Apache, look in the path var www.html. It's the path where most or all of the web server files are stored. If you're using Nginx, you can look for files or for suspicious files in this path. And sometimes it doesn't matter whether you're using Nginx or Apache. Just look for files in the temporary directory. Now you might be using WordPress, or you might be using some other content management system. In that case, you might need to look at the theme files or the WP content files if you're using WordPress. Most of the time, the web shell is injected into one of these files. I recommend, if you're using a CMS, just install WordPress plugin, which is a firewall. This plugin will scan your entire WordPress directory and find any suspicious files. Same for other content management systems. There are plugins that automate this work. Let's have a practical example. So suppose I want to find out where is this web shell located, okay? And I don't want to use the logs. I don't want to look manually in the web server files. What I could do here, I could use the find command. So find dash type F, here I specify the file type, and then dash name. Here I choose to look for all files with the extension PHP, because here I know what I'm looking for. I'm looking for a web shell that ends with the extension PHP or a PHP web shell. So dot or dot PHP. The asterisk here because I don't care about the file name. Okay, I don't know the file name basically. I just want to look for PHP files, and then I specify the location where I want to conduct a search. So let's say you want to conduct a search in the web server directory. You could just specify the location var.html. So here we have to include the location probably at the very first var.html. As you can see, I was able to locate all the PHP files that are stored in the web server directory, including files that are stored in the WordPress directory. So my web shell here is located among these files. One practical way is to pipe the output to the list command. So you could scroll through the files and make sure not to miss any important detail. As you can see, the first line is the web shell that we were inspecting earlier when we were interacting with it, basically. Another example to locate web shells or malicious files in general uploaded to your web server is looking through packet captures. So basically, packet captures are taken real time by some software such as Snort, Suricata IDS, and basically you should have a mechanism where you are recording packets in real time so that you could dump specific packet capture in a specific time frame. That applies in this case only. If you don't have packet captures, this method doesn't apply to you. So basically here we're looking at packet capture opened by Wireshark, okay? And as you can see in TryHackMe, they have shown how to detect the web shell by using specific filters. So the filter used here is the destination IP address and the user agent. And basically here you see we have multiple GET requests followed by one POST request to the detected web shell followed by multiple GET requests to interact with the web shell. You see, when one of the requests was inspected, it was posted to the web shell. The web shell name is upload_form. That's the user agent. As you can see, the shorthand user agent, and that's the contents of the web shell. You see, it's a basic web shell that uses the CMD as a query string. And you see the shell uploaded path and the name. Okay, now we have the questions. What command would you use to locate the PHP or to locate PHP files in the var directory? We just did that actually. Let's copy the command. However, here we're going to have to remove the HTML because we're looking at files under the www only. Okay, so find var www, then dash type, file dash name. We have dot asterisk dot php. Which Wireshark filter would you use to search specifically for put requests? So there is a filter to search for packets using the HTTP methods. It's basically here. That's the filter. However, we're going to have to modify the method. So here it is put. And on to the last task of this room. Lastly, in this task, we have an investigative scenario. So we have been given a temporary access to a compromised WordPress website and underlying server, which basically is the machine given in this scenario. We want to uncover the presence of a web shell, okay? And we're giving a couple of questions to answer. One tip to answer the questions here is to use cat and to investigate the access log. So we're not going to look manually for the web shell in the web files. We're not going to analyze pcap files or doing network analysis. We're going to use the log analysis method. So basically, we're going to have to look at the web server access log. Here, the web server is Apache 2. Runs a WordPress as a content management system. The access log file is access.log. So we look in this file to identify clues for the presence of a web shell. Okay. And we are given the questions. So how to start? First, let's have a look at the file. So the file is located under var log Apache 2 access log. Gonna copy this. Okay. And maybe we can have a first-hand look at the file and use this command. You see, looking at the file using this method is not nice because, as you can see, everything is inside it's like kind of messy, right? It's hard to read. So that's why it's always good to use grep, because investigating these files manually is tiring for your eyes. Gonna quit and use grep. Define what we're looking for here. So grep allows us to extract information using strings we define between the two parentheses. Double quotes, sorry. So here we're looking for example, if you're looking for 404 as given in the example here, you can spot 404 responses, basically non-existent pages or requests to non-existent pages. Now we have somewhat a response that can be read. However, we still have to simplify this. One way to do that is to use, again, less. So with less, we have all the requests that yielded 404 response or requests to pages that were not in the web server. Okay. You see, most of the requests come from the same IP address. And look at the user agent. We said earlier that user agents that are shorthanded, curl or strange in looks. Oops, we got disconnected. Okay, back to the investigation. Now, you see we have the same IP address is repeated across many attempts to access non-existent pages. This is actually an indicative of reconnaissance activity. The attacker is trying to figure out something on the web server. We still don't know yet. Okay. We can continue investigating to confirm that this IP belongs to the attacker. So press on space. You see now the attacker is probing files on the WordPress directory. You see all coming from the same IP. This confirms the theory that this is the IP address of the attacker probing for web server files or doing scanning on the web server. I'm going to copy the IP. Okay. The next thing we want to do, we want to find out what are the files or directories where the attacker was successful in discovering. This can be achieved by using 200 response code. So when you get 200 response code, it means that the resource you're trying to access is valid and was found on the web server. If the attacker got this response code, we can have a look at the files which have been discovered by the attacker. Let's have a look. Of course, we're going to correlate these results with the IP address. You see, we have the first request, get/WordPress, and we have also another request to /index book now, but it comes from an internal IP address. However, this does not mean that this is not the attacker who conducted the request, because when the attacker uploads, or after the attacker has uploaded the web shell, all the commands and all the requests they send come from within the system. So an internal IP address sending a GET request to the WordPress is not something normal. All the requests to the web server should come from an external IP. So this confirms the theory that the attacker now is probing or is accessing files inside the web server. And the first directory was /WordPress, which happens to be the answer for the next question. /WordPress. And the next thing we want to do here, we want to find out if the attacker has uploaded a web shell. Given that we know the attacker has found valid directories and is conducting the request from within the server, it means that the attacker must have successfully uploaded a web shell. Now it's time to find out the web shell. However, here we're not using, we cannot use the find command, right, to look for PHP files, because this is an access log. This is not a directory. Therefore, we're going to use post requests. So basically, if the attacker was able to upload a web shell successfully, there should be a post request, a successful post request that reveals the name of the file. So here we're going to look for post request using less. And this is the first one. So it's a post request to the login page of WordPress. Okay. Now the next one is a post request to the Ajax file. Okay. Next one again with the Ajax file, Ajax as well. The last one looks interesting. It's a post request from the external IP address of the attacker, and it is pointed towards the upload directory to upload a shady file named upload form. This is the web shell that the attacker has uploaded. So now we're going to copy this and answer with it. What is the first command run by the attacker using the newly uploaded web shell? Okay, You see here, take a look at this request. The attacker sent the request using, of course, his IP and using the user agent curl, which means that the subsequent requests that the attacker sent to the web server using the web shell or after the web shell was uploaded most likely come with the user agent curl. Let's test this theory. So we can search for curl here using grep. And we have first the request that yielded in the web shell uploaded. And next we have another request. It's to another file. It is shadi shell. And after the shadi shell was uploaded as well, we have, as you can see, a request, a GET request to the shadi shell with a query string cmd and a command whoami. So all the subsequent requests use the shadi shell, okay, with the query string as a parameter to store the executed command. The question here is, what is the first command? The first command was whoami. And after gaining access via the web shell, the attacker uses a command to download. The attacker uses the command to download a second file onto the server. What is the name of this file? The attacker uses a command to download a second file onto the server. So here the attacker also is uploading some file. So if you keep looking here, we should be able to identify this file. So we have command wget, which retrieves a file from the attacker's server. The file name is LinPEAS. Great. The attacker now is uploading an automated script that checks for privilege escalation vectors. So linpeas.sh. And lastly, the attacker has hidden a secret within the web shell. Use cat to investigate the web shell code and find the flag. Let's go back. Since now we know where is the web shell located, if you go back to curl, you see the web shell is located under WordPress, WP content uploads shadi shell. Okay, I'm gonna copy this path and basically cd to the path uploads to try var HTML. And that's the web shell here, cat shadi web shell, and that's your flag. Conclusion and wrapping up.